Okay, we're going to be looking at solving the oblique triangles, and this is the practice test solutions. And this is probably even a better one to look at than the test you actually took earlier, because the problems are probably a little more similar to this one, even though even the regular test was actually pretty similar to these questions as well. But if you haven't had a chance, download the copy of the practice test and maybe work through it first, and then go back and check your answers, and then work through this part. If you've done that, then this would be a great chance to see if you've got the ideas down. So here's problems 1 and 2. And again, what we're going to be looking at is you got to decide which are you going to be using. Are you going to be using law of sines or law of cosines? So the reminders that law of cosines, so if we do law of cosines, so I'm going to just write down cosines right here. We use when we have side, 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 and side, angle, side. The law of sines, we do it when we have angle, side, angle, and we have angle, angle, side. So when we get two angles. Then we have the special case of law of sines when we have two sides and a non-included angle, but we have two cases on this one. So we have two cases to worry about. Okay, so looking at this first example, I have angle, side, angle. So angle, side, angle, I'm going to use law of sines. So this is the law of sines. So sine of an angle over its opposite side equals sine of a different angle over its opposite side. Well, I've got this side of 18. So I need to know what this angle is if I'm going to use that formula. And I've got x and 48 degrees. So what I need to do is anytime you have two angles in a triangle, just go and find the third one. So if I do 48 plus 35 subtracted from 180, I get 97. Then I'll do sine of 97 over 18 equals sine of 48 over x. We cross multiply. Divide both sides by sine of 97. And, whoops, should be just x equals. And we end up getting x is equal to 13.477 inches. I will typically leave answers to 3 decimal spots, but I said make sure they're accurate to 1 decimal. So if you rewrote it as 13.5, that is correct. On the second example, we have side, side, side. So we're going to be using the law of cosines, which I ended up messing up. So there's the law of cosines. This will be up here, so it's c squared, and I'll rewrite it over here. Minus 2ab cosine of c. Now the big thing is you want to get the two sides and angles. So I'm looking for this angle. This is my grouping. So the part that I want separate is the 12. This one's not one that's not connected with the others. So the 12 is going to go where C is. So I got 12 squared is equal to 17 squared plus, and that should have been 26 squared. The calculation is correct, but I didn't change that. So 26 squared minus 2 times 17 times 26 times the cosine of x. When I calculate, I have to do 17 squared plus 26 squared. I get 965. 12 squared is 144. So make sure that when you're doing this, it's a little harder when you're finding the angle. You combine these two together to get that one. Then do 2 times 17 times 26 to get this value. And I have 144 is equal to it. Okay, so next step is I'm going to subtract 965 from both sides. Divide by negative 884. If you get a number that's bigger than 1, when I have to find an angle, then I made a mistake. Or if it's, less than negative 1. So if you see like negative 2 coming up as the answer, then that can't happen. So that means I made a mistake typically in my algebra, or the triangle is simply not possible. So I'll do inverse cosine of 0.9287, and I get 21.762, or you could have said 21.8 degrees. Okay, that's problem 1 and 2, just basically using law of sines and law of cosines. On question 3, we're going to be using the area formula. So we're told the area of this triangle is equal to 294. And again, whenever I'm going to use an area formula, I'm looking for side, angle, side. Well, I've got these two sides. I need to get the angle in between it. So what I'm going to do is use this formula, and I need to figure out what is this angle, because I can get that because I know what the area is. I've already got two sides, but I need the included angle. So I'm just going to call that theta. Take these three pieces together, and that's what's going to go in this formula. So I know 294 is equal to 1/2 32 times 28 times the sine of the angle between them. Well, simplifying that, I have 14 times 32 is 448. Divide both sides by 448. And I get 0.65625. I'm going to do inverse sine, and we got 41 degrees. Now, once I know this is 41 degrees, I will be able to use law of cosines because I have side, angle, side. So plugging in, we have x squared is equal to 32 squared plus 28 squared minus 2 times 32 times 28 times the cosine of 41. This you can calculate straight out on your calculator. And again, these are the three pieces that I had. This is on one side of the equation. And then the x is by itself. That's how the formula basically works. Calculate out, I get x squared is equal to 455.86. Take the square root, and I get 21.35. Now, what I didn't realize is whenever you're using law of sines to find a missing angle, even when using sine in general to find a missing angle, we could get two answers. And that's what I didn't show you guys in the original one. Now, I was anticipating it because I had kind of had the triangle drawn to scale, and we were assuming this angle is obtuse and not this one. Let's say I didn't give you the triangle and I didn't know that. Well, what happens when you're using the sine to find a missing angle, we could get an angle that's over 90 degrees. So if I do 180 minus 41, I get 139 degrees. This angle could have been 139. The triangle would look different. My triangle now would go like this. That's the difference, where this is still 28. This one was 32, but now this angle here is 139. Now, you didn't have to do this for the problem. Now, if I gave this on a test and I had a student realize it, I'd probably give them extra credit, saying, okay, you really understand this stuff because you realize, oh, there's another answer possible. So if I do my law of cosines, now plugging in 139 instead, you will get a different length for that other side. Calculating it straight out, I end up getting that x could have been also 56.218. So they're quite a bit different, So this one was one that I kind of made a little mistake when I set up the problem. At least I should have specified that the angle down here is an obtuse angle. Okay, solving triangles. When you go to solve a triangle, you need to first draw the triangle again. So I just draw any kind of generic triangle. I label it PQR. Then I'm going to fill in my information. I got angle P is 48. Side Q, which is opposite angle Q, is 8. Side R is opposite angle R, which is 15. Okay, well, now I know what to use. I've got side, angle, side. So if I've got side, angle, side, I can use the law of cosines. And I will find the missing side over here, which is QR, or side P. So I realize I use the law of cosines. I'm going to find P, which is going to be by itself. So I'll get p squared is equal to 15 squared plus 8 squared minus 2 times 15 times 8 times the cosine of 43. And that should have been 8 squared. Shoot, I hope this doesn't mess up my answer. Okay, calculating this out. Let me check to make sure. Okay, my work, I just didn't type it up correctly. When you do 15 squared, when you calculate this all out with the 8s, you're going to get 113.475. And then take the square root, you get 10.65. Now, you can also round it to 10.7 because I want it accurate to 1 decimal spot. So on this problem right here, when you're looking at it, as you go through with this, make sure your answers make sense. See, if this answer doesn't make sense, the answer right here, I see this is 43, probably means that angle R should be the biggest, angle Q should be the smallest. So when I work through my process, it should make sense. If I did have this as 18 when I did my calculation, then it would probably have shown that I would have gotten a little bit different answer over here. Probably something a little bit bigger. Okay, so when you do law of sines to find a missing angle, try to find the smallest one. 8 is smaller than 15 or 10.7, so I'm going to try to find angle Q. Even though it looks bigger on the diagram where I drew it, I'm going to do it right here. So sine of Q over 8 equals sine of 43 over the answer I just found. And I'm going to use the full answer as much as possible because it keeps my answers accurate. We cross multiply, divide by 10.652. I get sine of Q is equal to 0.5122. Do inverse sine, and you get 30.8 degrees. So that makes this angle up here 30.8. And then I'm going to use the sum of the angles in the triangle to find out what angle R is. So I did 30.8 plus 43, subtract it from 180, and I find that that angle equals 106.2, and then there's angle R. So usually when you're solving a triangle, you're going to have 3 pieces to find. Either 2 sides and a missing angle, you may be finding 3 angles, you could be finding an angle and 2 sides. There's different things you could be finding. Okay, question 6 is really the one that was meant to be for the ambiguous case of law of sines. We're told that angle P in the triangle is obtuse, and that's going to be important because I have a side-side angle situation. So what I've got is I've got sine of P over 25 equals sine of 28 over 18. So now when I solve for sine of P, cross multiply, we divide by 18, I get sine of P is equal to 0.652. When I do inverse sine, I get 40.7. So what happens here, this is the acute case. This is when the angle is less than 90 degrees. But I was told the angle was obtuse, so I'm going to have to do 180 minus 40.7 to actually find out what really P is. So it's going to be 139.3. Now I can use this to try to see about finding the length of PQ. Well, I'm going to use the law of sines again to find the missing side. And I actually could even use the law of cosines, but it just wouldn't be easy. Right here, the best thing to do, if you got 2 angles in a triangle, find that third one. So my third angle, because that's what I'm trying to find right here, is I want to find side R. I need to find this one. So that's going to be 12.7. Just did 180 minus the sum of 139.3 and 28. I got 12.7. Now I can do sine of 12.7 over R equals sine of 28 over 18. Notice I used the 28, 18 because I know those ones I didn't round. This is a rounded answer, so it would still work. It's just that you're adding an error possibly into your problem. Okay, cross multiply, divide by sine of 28. When I evaluate it, I get 8.429. So if you said it's 8.4, that would have been fine. Okay, our last problem was the application problem. So a patio is being constructed in a backyard with the dimensions shown in the diagram. It says find the length of the dashed line x. Well, I might be looking at this triangle to figure out x, or I could look at the triangle above. Well, I've got side, angle, side right here. So that tells me I can use the law of cosines to find x. So again, I'm going to use this. These three pieces are together. X is by itself. And again, I have 15 squared plus 12 squared minus 2 times 15 times 12. Cosine of the angle between them. When I evaluate this, I get 549. Take the square root, I get 23.43. So that's going to be important because I'm going to need that to be able to figure out what theta is in the next part. Now I've got side, 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 so I'm going to use the law of cosines again. So this time, these guys are together, and he is by itself. So 23.43 squared equals 20 squared plus 10 squared minus 2 times 20 times 10. 23.43 squared was 549. 20 squared plus 10 squared is 400 plus 100 is 500. 2 times 20 times 10 is 400. So subtract 500, divide by negative 400. I get 0.1225 equals cosine of theta. Do inverse cosine. You don't have to worry about any special weird things with cosine when you find an angle. I got 83 degrees. Okay, we're going to find the area of the patio. Well, I'm going to have to add up the area of this triangle and this triangle. So I'm going to call this maybe triangle A and this triangle B. Well, triangle A, I'm going to do 1/2 side, angle, side again. So 1/2 15 times 12 times the sine of 20. So this will give me the area of A. For B, I'm going to use the side, angle, side that's right here. So it's 1/2 20 times 10 times the sine of the angle between them. This will find this triangle. Calculating out each one, this first one gets to be 77.94. It's going to be feet squared. Then I'm going to add that to this one, which is going to be 100 times sine of 83, which equals 99.25 feet squared. We add them together, giving us 177.2 feet squared. And the last part is a volume part. We have, this is the base area, the whole thing, and I'm going to multiply it by a thickness. Well, the thickness is 3 inches. So I may think, oh, I'm going to take 177.2 feet squared times 3 inches. Well, my answer needs to be in feet cubed or inches cubed. I could do it inches cubed too, but that's going to make it more complicated. So what I need to do is I need to multiply by something here so I just get it in terms of feet. Well, I know that 1 foot is equal to 12 inches. So if I set up a ratio, I need the inches to cancel. And some of you may have seen this in your science class. This is dimensional analysis. I get my inches to cancel this way. Then I've got 177.2 times 3 divided by 12. I have feet squared times feet gives me cubic feet. And that gives our final answer. So good idea just to go through, study the problems, review them, try to work through the problems again. And if you know how to do the practice test and the original test, you should be fine on the retake.